Hey guys, today we're going to talk about the binomial distribution. Now let's start with an example, make it a little more practical. So Sarah's a basketball player who makes 75% of the free throws that she attempts. So if she shoots 4 free throws in a game, how many would you expect for her to make? Well, it should be pretty easy, right? You know that 75% is 3/4, or if you took that 75% called 0.5, if you multiply by 4, clearly you get 3, because 75% is 3/4. She made 3 out of 4 of the free throws, right? Easy peasy. But now, let's say we ask a slightly different question. What is the probability that she makes exactly 3 free throws? Now, your first thought might be, I don't know, 100%, that's what she's going to make. But then if you think about that, you're like, wait a second. I know she's not 100% guaranteed to make exactly 3, even though it's the most likely. So when we say, what do you expect? You just multiply the percentage and the number to get the most likely, right? I would expect 3 out of 4 free throws. If she keeps that percentage consistent, you know that she'd probably get 3 out of 4. Now, we also know in this case there's some human error, but let's say it's exact. Let's say you're rolling a dice with, or not a dice, but let's say you spin a spinner with 4 options and it's completely random, and 3 of them say you make the shot, 1 of them say you miss it. You know that if you did that 4 times, you're not guaranteed to get exactly 3 out of 4 because it's probability. Probability in general is those favorable outcomes over the total outcomes. So when we look at this 75%, the 75% is looking at basically one event. So if you have one event or one shot, your percentage of making it, or your likelihood, is 75%. Now, what are the 2 outcomes? Now, if all outcomes were equally likely, you just do 1 out of that. But the 2 possible outcomes are either you make or miss. Now, because this will start with M, I maybe use different words. We're going to say success or failure, right? So, again, if all outcomes were equally likely, you would just say 1 out of 2. In this case, it's differently weighted. We're making it 75%, but you know that overall there are exactly 2 outcomes. Now, what are all the possible outcomes in the overall situation, though, if you have 4 free throws? Well, the possible outcomes is you could make either 0, 1, 2, 3, or 4. Those are the possibilities, right? And we know these are not all equally likely. You're not just randomly picking 20% chance of each. So let's really think about what is the probability of each of those outcomes. So let's think, what's the probability of 0? What's the probability that she makes 0? So let's think about it this way. We know, again, there's 4 events, right? So overall, to get 0, she'd have to have failure, then failure, then failure, then failure. So let's think about what the probability for each trial is. Probability of success is 0.75. Probability of failure, you could always do by 1 minus the probability of success. It's clear to see that the probability of missing is 0.25. So what we're going to do, there's a multiplication principle in probability. The 0.25 is going to multiply. Now, kind of an easier way to show that is you could just type in 0.25 to the power of 4 because it's multiplied that many times. So if you do that, you can plug that in the calculator and you'll get 0.0039. That kind of aligns with what we know is that it's not very likely. If she makes 75%, she's not going to miss all 4, most likely, right? So let's kind of break this down and think about probability of making 1. Okay. Now again, if we think about the 4 events, we have to think about the ways that she could make only 1, because she could have a success, then a failure, then a failure, then a failure. Now, if we calculated exactly the probability of this happening, we do 7.75 times 0.25 times 0.25 times 0.25, right? However, that would not just give us the probability of 1 success. That's the probability specifically of making it, then missing it 3 times in a row. What we also have to consider is you could also or have a failure, then the success, then the failure, failure, failure. Or you could have failure, then success, then failure. Or, last possibility, of course, is you could miss the first 3 and then make it on the last one. Okay? So when you see an or in probability, right, that's an and. So it's this or, which means you add together this one. Now, if you think about the simpler way to calculate this, each one of these is really the same calculation. You've got 3 failures, so 0.25 cubed times 0.75. Okay? And then plus 0.25 cubed times 0.75 plus another 0.25 cubed times 0.75. Now, instead of adding it together 4 times, we know that repeated addition is multiplication. So the simpler way to really calculate this is that it's 4, because there are 4 different ways to have one shot being made, right? It could either be the first, second, third, or fourth shot. You do 4 times 0.75 times 0.25 cubed. Okay? Now if you put that into a nice calculator, you're going to get 0.0469. Okay? So let's continue on by thinking about the probability of 2 successes. Now, you might be thinking, wait a second, why are you doing all this work? It just asked for 3 free throws. Well, I'm trying to give us a depth of understanding of the situation and really calculate what's the probability of each option, and yes, we will get to 3. But the point of this video is for us to fully understand the situation, and the general name for a situation like this is called the binomial distribution. So let's look at 2 successes. So 2 successes, let's think about all the different ways you could have that. Well, you could do success, success, failure, failure, or, yeah, I'm going to not do the blanks this time, just write it like this, success, failure, success, failure, or, imagine I just move that success down, success, failure, failure, success, or, what else could happen? I could have failure, success, failure, success, or I could have failure, failure, success, success. Let's see, are there any more? Let me think about it. Ooh, what if we had the failures on the end and the successes in the middle? Okay, so that's 6 possibilities. Now, I want to pause a moment and think, is there a better way, especially if we have more numbers or a bigger situation, is there a better way to calculate this? Well, in fact, yes, there is. It's called the combination. So what we did here is really, for the probability of 1, it was the combination for choose 1. So the formula for that is it would be 4 factorial over 3 factorial, 1 factorial. And if you do that, in fact, you will get 4. And that is how the 4 goes here. And sure enough, if we double check that, the combination of 4 choose 2 would be 4 factorial over 2 factorial, 2 factorial. Now, because the general, I should pause and cover this, the general combination, if you have like n choose k, a certain number of things, and you have to choose the number of ways you could rearrange those, it's n factorial over n minus k factorial, so the difference, and then k factorial. So that's why I have the difference and the number itself factorial on the bottom. If you calculate this, you're going to get 6. Aha, so that confirms that we do in fact have 6. Now in this case, what we're going to do then is we're going to do 6 times 0.25 squared times 0.75 squared. Again, squared because there are 2 successes, and squared here because there's 2 failures. So if you put that in a handy-dandy calculator, you're going to get 0.2109. Now, finally off to the question that it actually asked. I know I'm going very more in depth than needed for this particular question, but what's the probability of 3 successes? So instead of jumping to list out all the different possibilities, let's jump right to the calculation of, you have the combination of 4 choose 3. That would be 4 factorial over 3 factorial, 1 factorial. Oh wait, it's the same as that calculation, really. So it's still 4, which also makes sense because making 3 means you only miss 1, so you could either miss it on the first, second, third, or fourth shot. So this calculation is going to be 4 times 0.75 to the 3, because we made 3 of them, times 0.25 just to the 1. We leave it there. So put that in a calculator, you get 0.4219. Aha, so this is the answer to the question, what's the probability that she makes exactly 3? And it's 42%. Now, it's the most likely, it's less than 50%, but it's more likely than the other options. Now, to prove that, let's just think about the last option, probability of making all 4. Again, on the ends, this is the easiest, because if you think about that, there's only one way to make all 4, is you just make all of them. So in this case, you'd have 0.75 to the 4th, and you get 0.31. Again, the second most likely option, so pretty good. So she's feeling pretty good to make at least 3, because high probability of 3 or 4. But to answer the question, it's a 0.4219 chance, or about a 42% chance that she makes exactly of the 3 free throws. So this situation, I calculate each one as a really good example of the binomial distribution. In fact, we can really see why it's a distribution if we look at a graph of it, which I'm going to show right here. The technical name for this is called the probability mass function, but basically on this axis you have basically the number of shots that she made, and then on the other axis you have the probability. So the probability mass function is what shows the probability for each of the shots made, and of course we see that you would expect the most likely is 3 out of 4, but again, it's an important thing to think about, because the probability of getting that is 42%. So if you were to bet on, is she going to make exactly 3 shots or not, somebody who's just kind of thinking more straightforward, if you're thinking, oh, the most likely, I would expect her to make 3. Like if you told your friend, hey, I bet you $20 she makes exactly 3, that would not be a good bet, because it's more likely that it's one of the other options. It's just the most likely of those. So now let's talk about the actual definition of the binomial distribution. So again, I said the last example was an example of this. A binomial distribution is a discrete probability distribution that describes the probability of obtaining a certain number of successes in a fixed number of independent trials, where each trial has only 2 possible outcomes. So again, this one, 2 possible outcomes, you could make it or miss it, and there is a fixed number of trials, 4 trials, and then your x, or your variable, is basically how many of those do you make. Now, this looks kind of complicated, but it's really what we did, right? This part is the combination, n factorial over n minus x factorial, then the probability to the x, and q is the probability of it not happening, which is found by 1 minus p. So let's look at one more example of this. So in this example, a casino has a roulette wheel that has 38 slots, 18 red and 18 black and 2 green. A player decides to bet on red for 10 consecutive spins. Complete the table below by calculating the probability that the player will win exactly X number of times. So what we're doing here is really calculating the entire distribution of all the options. Okay, and this is to kind of show what we mean by probability distribution. Just like the last one, I showed like a small graph that you can plot all the values of X. That's what we really mean by distribution. So in this case, remember the formula. In this case, again, you have that first of all the combination of 10 choose X. So the X is the variable that's going to change, and it's going to be times your probability of success to the X times Q, which is the probability of not success, to the 10 minus X, like the number of times you want it to not happen. So in this case, again, your probability P would be 18 out of 38. We could leave it like a fraction. And then so the probability of Q, you could say 1 minus 18 over 38 would give you 20 out of 38, because it's the 18 black plus the 2 green. Now, it would take a long time to go ahead and do all of these, because you've got a lot of combinations to do. So that's why part of this example, I want to show how you can use some other online tools to help. So I like this website, the stattrek.com/online calculator. There's lots of different statistics calculators. I have another video where I show the normal distribution, which is another distribution. The only thing is when you put in the probability, you can't do a fraction like this. You can't just put in 18 over 38. So what we got to do is we just got to calculate, well, what is 18 divided by 38? And we get 0.47368. And we can probably round it. Let's do 5 decimals. I think that'll be pretty accurate. So 0.47568. Now, number of trials we had was 10. Now, for the first slot, I'm going to say 0. And what I could do, it's going to calculate like this. So, binomial probability, I would put the 0.0016 right there. And then I could just go through each of these. I calculate 1. And then I hit calculate, and it gives it to me, and then 2. Now, when filling out a table, though, there is a way that is even better than this one. This is a great website for overall calculations, but when you're doing something like filling out a table, I really like using spreadsheets. Alright, so you just put your numbers here for the number of wins that you want, right? And then over here, the formula, you press equals binomial, and you look for this, binomial distribution. It tells you what to put in. We'll put the number, and I'm going to click this cell, so when we drag it down, it's going to get all those. Number of trials, we said it was 10. Probability, in Excel, you actually can just say 18 over 38, because remember the probability was 18 over 38, comma, you're going to hit false for this. Now this is saying cumulative. I don't want cumulative, I just want the probability of each one. So if you drag it down, then it's going to show you all these. So this is the table that answers that. These are the probabilities. So for example, the most likely one is 5. Most likely he wins 5 times is like 24%. Again, for him to win 10 times in a row, very unlikely. So probably he's going to win about half, which kind of makes sense. But you know, a little bit less because 18 out of 38 is a little less than half. Now, if you're wondering what the cumulative was, if I type in the same thing over here, actually first I'm going to make a graph of this. I want to show you how to do that too, in case you want to do that. So select, then you can just say insert recommended graph. Let's do that. Boom. So this is a good visual of the binomial distribution. We got the numbers in there, and this represents the probability of each of those. You can see very nicely visually. Now, I want to show too what the cumulative. So you say equals binomial distribution, and then again I'm still clicking this one, still 10, still 18 out of 38 is the probability, but the only difference is I'm going to say true. Okay, so what this does for each thing, I'm basically saying what's the probability that it's less than or equal to this. So the probability of less than or equal to 10, of course, is 1. Less than or equal to 0.68. So that's cumulative. And then if you were to graph that, let's see if it gives us a good recommended graph. Boom, exactly. So this would be the cumulative graph. Look kind of like that. So that's just a little bit on how to use technology to help making these distributions easier. And that's what makes these probability distributions really the bridge between statistics and probability. Again, this is based in probability, but again, what we're really doing too is now we have a data set that you can also find statistical measures like the mean, the variance, and the standard deviation. And of course, there's traditional formulas you could use for that, but when it's specifically a binomial distribution, there's a shortcut. So the mean, a lot of times we'll use this symbol right here, Greek letter mu. Instead of, let's say if I had that table before, instead of adding up all the things and finding the average and dividing, I could just do n, the number of trials, times the probability. And that would give me the mean or the average. Now, if I wanted the variance we usually use this symbol sigma squared. The variance then is also very simple. It's just n times p times q. So q, remember, is the probability of not happening. So you could think about it as n times p times 1 minus p, or you could think about it as just mu times 1 minus p. And then, of course, the standard deviation is just the square root of the variance. So you could find it simply by square rooting the variance, or you could write it as the square root of n times p times 1 minus p. So to close off, let's look at some examples of finding the mean, variance, and standard deviation. So let's say at a certain college there's 30% of students that are engineering majors, and groups of 10 students are chosen at random. Answer the following questions about the groups of 10 students. What is the mean number of students who are engineering majors? So if I pick a bunch of groups of 10, on average, how many of them are going to be engineering majors? Well, it is probably as simple as you think. In this case, yes, you just do 10 times 30%, which you get 3. That is the mean. Easy peasy, right? Piece of cake. Because it makes sense that even though if I had a bunch of groups of 10, some of them might have 4, some might have 2, some might have 5. On average, probably going to have 3, right? Now the variance then is pretty easy. Just one more step. Again, this we use the Greek symbol mu. Variance is this one. We do 10 times 0.30 times the probability of not happening, which is 0.7. So if we put that into a calculator, you're going to get 2.1. Okay, so what that means is, again, your variance, that's a measure of how much it varies within the data set. So there might be some groups of 10, again, that are bigger and smaller. I have another video on measures of variability that go more into depth on what standard deviation and variance are. But then if you wanted the standard deviation, I would do the square root of that. Now, because I already have this number, I can just calculate the square root of 2.1, and I would get about 1.449. So that would be my answer here for standard deviation. And again, if let's say it had only asked for what is the standard deviation, you wanted to calculate directly, you could also calculate it like it is 10 times 0.30 times 0.7, which you could also get as 1 minus 0.3. You would also get the same thing, 1.449. All right, let's do one more example like this. So let's say a certain company, 18% of the employees work in the IT department. Teams of 12 employees are randomly selected for a project. Answer the following questions about these sets of 12 employees. So what is the mean number of employees working in the IT department? Well, just like before, we take the percentage as a decimal and you multiply that by 12 and we get 2.16. So again, the average being 2.16 people, it's okay that you can't actually have 0.16 of a person. That means that's just an average, right? That's how many IT people would be in each group. Now, the variance, again, you could just take this 2.16 because if you remember variance, you could just think about it as mu times q. So the most efficient way to do it, we could do 2.16 since we already have that number, times, we could write it as 1 minus 0.18. Again, you might know it's 0.82, this part, but we can just calculate it like that. 2.16 times 1 minus 0.18, and you get 1.7712. Again, if you wanted to calculate directly, like if it didn't ask us answer A, and you're already just looking at the original problem, you could do 0.18 times 12 times 1 minus 0.18. You get the same thing, right? And then finally, standard deviation. Well, of course, simplest way, take the square root. Since we already have that number, if you square root that, you should get about 1.33. I'll just leave it there. And again, it's the same thing you would get if you did 12 times 0.18 times 1 minus 0.18. You get the same thing. Cool. So hopefully that helped. A solid understanding of the binomial distribution. We covered what is the binomial distribution, how to calculate it, and how to use some tools of technology to help you calculate the distribution, applying what it means, and being able to find the mean, the variance, and the standard deviation of a binomial distribution.